All right. Sometimes, most of the time, when I give you a piece of information and I ask you to prove something, your knowledge alone isn't good enough. I know that might be hard to take. All right, but your knowledge alone isn't good enough. I need some things that will connect your knowledge to what I'm asking you to prove. All right, and these connectors are called postulates. Remember we had theorem last unit? Vertical angles are congruent, linear pairs are supplementary, and I said a theorem is a fact that can be proven. All right, well, when I show you some of these postulates today, they're assumed to be true. They can't be proven true. All right, they're just assumed true. All right, assumed true. So the first postulate I'm going to show you here, and this one's tough for you guys to buy in, is called the reflexive property. Here's what it says. A quantity is equal to itself. Wow, huh? You're like, thanks for the update. Look at my examples. AB equals AB. Shocker, huh? And angle B equals angle B. Shocker again, huh? Okay. I know this doesn't, you're maybe like, who cares about this? It will become useful before you leave the room today. And you'll be like, oh, now I understand why I need this reflexive property. Okay. Everybody good on reflexive property? Gave you a couple examples. All right, substitution postulate. You guys have actually used this your entire algebraic career. All right. If I have, and you don't need to write this down, if I have 3x plus 7 is equal to angle B, and I tell you x equals 5, what are you going to do with that 5? What are you going to do? Everywhere you see an x, you're going to substitute it in. We can do that for angles and segments too. All right, we can do that for angles and segments, just not variables. Take a look. Oh, forgot. Every time we do a property or a postulate, it goes up here. Reflexive. Just a reminder, because we're going to have probably, I'd say, 8 of these sooner or later. And then we got another set of them coming up next week. Okay, so a pink set coming up for the angles. All right, so how to use substitution here. Everyone take a look at these 2 statements I've given you. All right, everyone see our statements reasons. That's what I had you guys set up yesterday. AB is equal to twice the length of AD. Okay, we don't need a diagram for this. AD is the same measure as DB. Do you see a substitution I could make here to tell me a true statement in return? AB is twice the length of AD. Well, hey guys, AD is the same measure as DB. Can you write a true statement, a second true statement right now by substituting in a quantity for another? Can we do that? See if you can right now in your group. It's going to be a little awkward for some of you because you're just not substituting in a number anymore. You're actually substituting in a segment for another segment. Any group think they have it here? Any group think they have it? A true statement. Meg, you think your group has it? AB equals 2 times the length of DB. That is correct. Let's see how that group got it. What was AD the same measure as? DB. So all they did was take DB and substitute it in for AD because they're equal to each other. And what made that statement true? Substitution. Okay, that's what we're going to write here now. Substitution. Anytime I use it, we're going to write it as a reason. Substitution. Can you do the same thing in my next example? Angle A plus angle B equals 90. And angle A and C, same measure. Can you guys write me a true statement using the substitution postulate? We're not done yet. Calm it down. Easy. Another group. Want to give me what they plugged in for substitution? Nothing. Come on. Oh, here we go. What do we got over here? This stud group. M. Yeah, thank you. How about we start talking some mathematics? The measure of angle C, yep. And how'd you guys get that? You knew that A and C were equal, so you took C and substituted it in for angle A by substitution. Everyone all right? No issues there. No issues? Okay. All right, here's the big one for today that we got to stop and focus on here. But before we do that, let's put substitution up on the board. You guys are the first class of the day that I teach this to, so luckily for you, you guys get to see them put up on the board because I don't take them down after this period. All right. Before I get into this next postulate, I got a question for you here. All right, I'm just going to call this one segment A, segment B, segment C, and segment D. Okay, everyone ready? What do you know about them? What do you know about C and D? Okay, if I put A and C together, and then I put B and D together, what are you going to know? Will their results be congruent? Okay, so you're saying if I put A and C together, that'll be the same as B and D. Everyone agree? Okay. Is there another pairing I could put together here and still be equal to each other? Other than A plus C, B plus D? A and D plus A plus D equals B plus C. Okay. Why is this all true? Well, when you add a pair of equal quantities to another pair of equal quantities, their results will also be equal. This is called the addition postulate. All right, the addition postulate. If equal quantities are equal to equal quantities. Now, hey, before you're allowed to use this, and I'm going to sound like a broken record with this, you need two pairs of equal quantities to add together. If you only have one, it's not good enough. You need two pairs of equal quantities to add together. All right, so everyone see how I have given you two pairs right now, A and B, C and D. All right, and we just kind of did this with the line segments. So if I went A plus C, that'll be equal to B plus D, or we just also figured out what? I could also add what? A and D, and that'll be the same as B plus C, the addition postulate. And you guys, you don't have to write postulate every time. You can write addition, substitution, and reflexive. You don't need to give me property or postulate after it. Okay? Got to have two pairs of equal quantities, though. Are we ready to put all this together? Because this is a big moment for you right now. This is your first geometric proof of your mathematical career. It's huge, huge. It's like the first day of school, first day of kindergarten. All right, it ranks right up there. All right. Okay, let's look at our givens. Hey, here's how a proof is set up. I'm going to give you, remember that. Remember I showed you yesterday. I'm going to give you some information. Here's what I need you to prove true. Okay, here's what I need you to prove true, that A, C, and DF are equal. First thing, get in the habit of, whatever's given, mark it on your diagram. AC equals DE, or AB, sorry, AB. Okay, AB equals DE. Am I that loud that it triggers that? I found this on the web for ACDF. Okay. I didn't know it was that loud. I could trigger the button without pressing it. Also, BC is congruent to EF. Get used to that. Mark it on your diagram first. Mark it on your diagram. Okay, let's discuss now. What am I asking you to prove is true? AC, same measure as DF. AC. Searching for same measures on the App Store. All right, I'm done. I can't deal with this. It's like somebody's got hooked onto my phone here. Let's try to bury this now. I don't have any other additional steps. I hope that works. Okay. I'm asking you to prove that the measure of AC is the same measure as DF. Let's see if we can do that. What did I write in statement 1? Just like we did yesterday, what did I write in there? The givens. You're welcome, by the way. You don't have to write that down. All right, but if it's not in there, that's the first thing that goes in are your givens. Okay? Next step. Let's start talking about this because now you guys got to take over with your knowledge. Okay, I can't hold your hand here anymore. How am I? Look at what I was given here. How do I go from giving these two pieces to the full one? These two pieces to the full one. What do I have to do with what I was given to get to what I need to prove? Am I getting bigger or am I getting smaller? I'm getting bigger, right? So if I'm getting bigger, the only way I can do that is adding something together. So we've identified that we're going to use addition here. Everyone agree? Okay, but before you get going, how many pairs of equal quantities do you need to add together? 2. How many was I given? Perfect. All right, I'm ready to add them together. Is everyone good? Everyone, why we're adding? And we can add right away because how many pairs of equal quantities was I given? 2. All right, so in the next step, I need to show me what you're going to add together. Okay, here we go. Show me what you're going to add together. You're going to take AB and add it to BC. And you're going to tell me that's the same as adding what? DE and EF. Why is this statement true? Not because I said so, but by the addition postulate. Or you can just write addition. Okay, but this is what I need, AC and DF. I don't see that yet. This should be the very last step in all your proofs is what I'm asking you to prove. So how do I go from here to that last step? What is another name for AB plus BC? AC. I'm not going to say anything here. What is another name for DE plus EF? That's not addition, though. What did I just do? I took AB and BC and substituted in an equal, AC. This is substitution. Did I prove what was asked? Okay, do you see how this goes now? I'm going to give you some information. You got to take a look at the diagram and your knowledge and some of the postulates I've given you. Try to connect it. And again, guys, these are only going to be 2, 3, maybe 4 steps. Okay, we're not at the, sooner or later we'll get to 8, 9, 10 step proofs, but for now, don't expect it to go above 4. Okay, or you're doing something crazy. Whoa, we got to celebrate this big moment. All right, this is always a tradition in here. Congratulations, everybody, on doing your first geometric proof. This is the only time I'll allow this. I will give you about 2 to 3 minutes if you want. If you have your phones on you to get together with friends or by yourself, take a selfie with your new proof, with your first geometric proof, and put it in your file somewhere in your phone because this is huge here. Put it on your Snapchat story later on. All right, so I'll give you about 2 to 3 minutes. If you want to get together with somebody, show them your proof. This is a big moment in your mathematical career, your first proof. All right. All right, so let's keep going here because obviously 1 doesn't make us great at all. Let's go to the next one now. Now we go to angles instead of segments. The measure of ADF is the same as the measure of CBE. Can you mark that on your diagram? Get in the habit. Whatever's given, mark it on your diagram. What type of symbols are you putting on your diagram to represent their congruent? Arc marks. So ADF, find it. ADF is congruent to CBE, find it. Hopefully you have those 2 angles marked. Everyone follow it with your fingers if you need to. And then EDC. Find EDC. EDC is the same measure as ABF. So hopefully we have those marked right now. And what am I asking you to prove? That ADC, this angle right here, is the same measure as ABC, this angle measure right here. Okay? And it's not going to be tough today, all right? Because look, you only have 3 to use. All right, once I start adding more and more and more, that's when it becomes difficult. So it's ultimately important that you guys get this down, because if you don't, when I add more, it's just going to snowball on you, unfortunately. What am I going to do to the 2 smaller angles to get to the bigger one? Does everybody see where addition is coming into play here? I'm going to take these 2 smaller angles and add them, and take these 2 smaller angles and add them. Whoa, hold on. You said add? How many pairs of equal quantities do you need before you write that word addition down? 2. How many did I give you? 2. All right, here we go. First thing that's got to go in, sorry I didn't write this for you, is your givens. Yep. Now let me just address this, because there's 30 of you in here, and even in an honors class, you do get a lazy person from time to time. I know. Can you believe it? Here's what I'll usually get. Instead of writing them out, they'll just take an arrow and point it down there. That's fine for homework, but test or quiz, everything's official. Write it all out for me. Okay? I don't care what you do on your homework, all right? But as far as tests and quizzes, write all the givens out. If you just want to put an arrow in there for homework or notes, that's your deal. All right, and you said, what are we doing to these 2 angles to get to the larger one? We are adding them together, all right? And we have 2 pairs of equal quantities, so we can go right to addition. What angles are we going to add together? Angle, make sure the correct angles are written. Angle ADF plus the measure of BD or EDC, BDC. It's all the same one. And that is the same as what? If I add what other pairs here? Ryan, go. CBE plus measure of ABF. Yep. And why is this statement true here? Why are these 2 added together the same as these 2 added together? What tells me that? Addition, when you add 2 pairs of equal quantities, the results are equal. But again, that's not what I asked you to prove. I asked you to prove these whole angles. So what is another name for ADF plus EDC? ADC. So the measure of ADC is equal to, what's another name for CBE plus ABF? ABC. And what gave me the ability to write that? Substitution. These are pretty easy. I just write given, addition, substitution. These are easy. Okay, wait to the next one. Wait to the next one. Any questions from you guys right now? Are we picking this up? Why I'm adding? And this is all, tomorrow we'll subtract and do some other stuff, but for today it's just adding. We're okay. All right, let's see who's on top of their game now. All right. So you'll probably see something different right off the bat. How many givens did I provide you? Only 1 versus the 2 in the last proof, 2 proofs. Yep. All right, so let's just mark our diagram and talk. There is no diagram?
Well, it's the same one as
Oh, it's the same one as above? Okay. Thank you. DE is the same as BF. Got it. Let's just put that in our givens right now so we can talk. Okay, everyone ready to talk about this one? Okay, look at what I gave you. DE and BF, everybody see those segments. And I'm asking you to prove DF and BE. Are you guys, from the givens to the proof, are you guys getting bigger with the line segment or smaller? Bigger. So if I'm getting bigger from the givens to the proof, that usually means I have to add on something to get bigger. If I was getting smaller, I'd subtract. That's tomorrow. If I need to get bigger, so I'm going to add in on. So let me ask you this. Take segment DE, which was given to us. What must you add on to DE to get DF? EF, right? Everyone agrees I have to add on EF. All right, what do you have to add on to BF, the segment I was given, to get to BE? EF again? So you're telling me you need to add, okay, the same segment to each of these. Okay, but what's my requirement before you add? You need 2 pairs of equal quantities, and how many did I give you? 1, so you're not doing addition in step 2. You don't have enough pairs. You only have 1 pair. You have to provide the second pair now. It's not as convenient, is it? Because I didn't give it to you. But you guys already told me what is that second pair I need to add to both of these. I need to add EF and I need to add EF. Hey, what do you know about EF and EF? They're equal based on what property? That's where we're going to use it, when we need a second pair of equal quantities. Okay, so if we decide, hey, I have to add in this problem, but I only have 1 pair of equal quantities, that second pair is probably going to come from a reflexive. All right. Now do I have 2 pairs of equal quantities? So now what can I do in step 3? Now I can add it. Specifically, what pairs do you want me to add together? DE plus EF is the same measure as BF plus EF. And that's by addition. That's not what I asked you to prove, though, right? What did I ask you to prove? DF equals BE. So what's the same as DE plus EF? DF equals BE. Substitution. So does everybody see? You may not be given 2 pairs of equal quantities. That second pair will come from a reflexive pair, probably. All right, and I believe that is it. All right, so you guys are going on your own right now. I just want to warn you, though. I don't want you guys to always think this is given addition, substitution, or reflexive. Let me just take a peek at the homework right here. Hey, take a look at number 5 right now. Take a look at 5. Number 1, I want to pay attention to the directions. It says write a formal proof. When you see formal proof, that's statements, reasons. Okay, statements, reasons, givens, step 2, step reason 2, statement 3, reason 3. All right, take a look at number 5 real quick. I don't want you guys to start getting intimidated right off the bat. NP equals 2 inches, QR equals 2 inches. That was given. I am asked to prove why NP is equal to QR. Am I adding anything here? No, so don't put addition in here. Don't think it's the same every time. What is this actually going to be here? Anybody know what this is, how I get NP equal to QR? Ooh, reflexive is it's equal to itself. It would be NP equals NP or QR equals QR. This isn't reflexive. What are you doing? You're taking the QR and substituting it in for 2 inches. Does everyone see that? So all this, and this is the only one I'm going to give you. This will be statement 1 is your givens, and then statement 2 will be NP equals QR by what method? Substitution. Okay, guys, reflexive is only a quantity equal to itself. All right, these are two different segments. All right, I'll let you go on your own now, work in your groups, call me over if you want me to take a peek at your proof or if you're stuck.